terms of detection, how does the Accelus platform help detection of failure modes? Well, I can give you one of the examples we're working on currently with a partner in Denmark, which is to instrument offshore assets. For example, we've made a wind turbine model with them. So they had data for a wind turbine. We created a digital twin of a wind turbine, and the idea is you put accelerometers, sensors on the model, and anytime you basically have signatures that you're looking for. So if a certain signal occurs, you know that matches with certain behavior that you're worried about, and then you can obviously run algorithms that update your model such that they match the sensor data, and then you're able to identify any issues with the actual asset in that way. So yeah, it's really basically the idea is to calibrate the model based on the data you have, and once you've calibrated it, that's what enables you to diagnose what's really going on. So as I mentioned, accelerometers are one key tool. You put your accelerometers on a structure, the structure is vibrating, and then based on the particular vibration, the particular environmental load that you've detected at that moment, you're able to calibrate your digital twin, and then you set all the parameters such that you're saying, okay, this is the current state of the asset. Then you run 1,000 different simulations for 1,000 different scenarios, which is very quick because of our fast technology. And with those, it's really the 1,000 extra simulations that you run that allow you to diagnose what's wrong, right? You've got a digital twin that is calibrated, then you can use that for diagnostic purposes, okay? So the sensors are really for the calibration, and then once it's calibrated, you've got a model that you can then use to understand what's really what would happen now if a storm occurred? What would happen now if the wind doubled? What would happen now if I doubled the throughput in this asset? That's really what you're able to do. Is you've got the calibrated model, you can then use that for these risk assessment purposes, and that's really a unique capability that we provide because no other software can handle this large, fast modeling of these critical assets, where this calibration is computationally intensive. Okay, calibration is essentially an optimization problem. Okay, so the way you calibrate something is you take measurements, and then you've got your computational model of the system, and you want to match your computational version of those measurements to the physical ones, and that requires iteration. You have to modify your model many times, maybe 1,000 times, until you get a good match with the measurements. And if each one of those modifications and reanalyses takes hours, days, then it's completely impossible to do this calibration. So what we provide are these fast parameterized models which can be modified easily and solved easily, which means this calibration phase is extremely quick. So that's why we see our technology as being a really complementary fit with the rise in the Internet of Things, the industrial Internet of Things, and the sensor technologies that are really predominant today. When you create a three-dimensional geometry, so the question is what is meshing? So it's really a core part of finite element analysis. So I referred earlier to the way finite element analysis is based on building blocks that are just geometric and don't have any physical representation of what's really happening. But meshing is the process of creating those geometries out of those building blocks. So we use meshing the same way FEA does, but then we build an RB layer on top which provides acceleration. So I guess one thing I do want to emphasize is that the reduced basis technology we provide is very much complementary with conventional FEA. We see conventional FEA as an important piece in the value chain. We provide cloud-based conventional FEA in a fully scalable, fully parallel way. We also provide the unique RB-FEA solver. So we provide this interplay between the conventional approach and the unique Accelus approach, which we think is a very nice way to provide a sort of end-to-end analysis tool.